Welcome back to our summer webinar series on operational waivers for unmanned aircraft systems. I'm Kevin Morris, an FAA safety inspector here, and today we're on episode number 9, which is going to detail operations over people, specifically going through the waiver process to receive your permission to operate over people under Part 107. A few things as we get started here, as throughout our entire webinar series, we are recording this episode, which will be broadcast later, and I'll get you that website information at the end. The audio is through your computer speakers, and the Q&A pod is active at the bottom of the screen at this time. We use that pod to give you access directly to a room full of subject matter experts on all things related to Part 107. That's legal, air traffic control, it's the waiver team, it's flight standards, communications, anything that you have a question about for Part 107 operations, put right into that pod there at the bottom of the screen, and that question will be submitted to our group of experts. Following the content of the presentation today, we will once again do our live Q&A, which will give you a chance to ask me a question directly on the air, and if I can't answer it, we'll certainly make sure it does get answered later on. So, why are we here today? While operating over people is not our most often requested waiver, I would bet that it's probably the most often talked about waiver in industry. So what I want to go through today is a little bit on operating over people, detailing the risk associated with that type of operation, knowing what we, the FAA, expect in your waiver application, and we're going to do that, as always, through discussing the waiver safety explanation guidelines. So let's start with the rule itself, because I don't know of many other rules in Part 107 that create so much discussion for terms and what they mean. So let's talk about this. 107.39 is the rule that states no person may operate a small unmanned aircraft over a human being unless that human being is directly participating in the operation of your aircraft, or they're located under a covered structure or inside a stationary vehicle that can provide reasonable protection from a falling aircraft, from your falling small unmanned aircraft. Let me break down that first term, directly participating. Advisory Circular 107-2, which is available on the left side of your screen there in our downloads if you want to get it. It's also, you can find it online. It defines directly participating as these individuals you see on the screen. We're talking about the remote pilot in command, a visual observer, a person manipulating the controls of the aircraft, or crew members that are necessary for the safety of your operation as assigned and briefed by the remote pilot in command. So those are the individuals that the rule references as directly participating. Now, let's talk about crew members. Crew members necessary for the safety of the operation. These individuals do not include actors or actresses or on-screen talent, a television reporter perhaps, or, and I've seen this a lot of times and people have asked me about it, people you've notified of your drone operation. You can't simply put up a sign that says there is a drone flying over your head and consider those people briefed and crew members for your operation. Remember, crew members are folks that are necessary for the safety of your operation. So let's move on to the big one, right? What does operating over people mean? Operating over people means an operation during which a small unmanned aircraft passes over any part of a person who is not directly participating in the operation. Now, we've already talked about what directly participating in the operation means. So let's talk about over. The simplest way to think about this is to extend an imaginary cylinder around a person that extends vertically into the airspace. If your small unmanned aircraft were to pass through that cylinder that surrounds that individual, you would have been considered to be operating over that individual. Now, that cylinder can change shape, it change diameter a little bit, so to speak. If your arms are to your side, or if the person's arms are extended out wide, or if they're laying down on the ground, obviously the cylinder is going to have some different diameters or shapes to it. But regardless of what diameter or shape, if you pass through that cylinder, that imaginary cylinder extending above that person, you'll be considered to have been operating over that person. So, if you're not operating over somebody, that means you could fly 5 feet from that individual and not be over that person. While that's true to meet the requirements of 107.39, let's keep in mind that as a remote pilot in command, you also have to comply with 107.23a, which details hazardous operations. 107.23a states, a small unmanned aircraft system may not be flown in a careless or reckless manner so as to endanger the life of another. So what that means is, even though you may not be flying directly over someone as the rule references, you still need to be aware of the direction your UAS is flying. For example, are you headed toward a group of people? What speed are you flying towards that group of people? Will the wind push your unmanned aircraft towards that group of people? And are you operating at an altitude whereas if the aircraft were to fail, there's a chance that it could drift into those people? Certainly you could be flying in all those conditions and not be over people, but if you're in a situation that's creating a careless or reckless operation, you'd be in violation of 107.23a. So there's certainly rules for operating over people, which we're going to focus on, but don't forget 107.23a, which details a hazardous operation. So our waiver policy in 107.200 grants the FAA permission and states that we may issue a deviation to 107.39, operations over human beings, if the applicant provides a complete description of the proposed operation and justification that the operation can be safely conducted. These are the same requirements you have for beyond visual line of sight or operating altitude or daylight waivers. So before we get into the actual waiver safety explanation guidelines, let's talk a little bit about some of the risks that are inherent with operating over people. Clearly, risk number one would be we have an increased potential to injure those people that are going to be below our aircraft. There's also a possibility that humans may interfere with your operation, and that malfunction or failures in your small unmanned aircraft become more critical because now we're not talking about perhaps crashing into a field. We could be crashing into a group of people. So failures or mechanical issues are more critical when operating over people. But let's talk about the number one issue here, and that's making sure that people beneath your unmanned aircraft are going to remain safe. That has a lot to do in terms of the severity of injuries you may cause, related to your SUA design, related to the blade construction. Is your unmanned aircraft plastic, or is it made out of composites, of fiberglass, some sort of honeycomb material, or is it metal? Because the differences in construction and design of the unmanned aircraft or blades will affect the injury potential. When we're talking about rotating blades spinning somewhere in the neighborhood on average 5,000 to 7,000 RPM, they can create severe lacerations. And if you look at the photo on the right, that is some injuries that were caused by a blade on a small unmanned aircraft. But if you really want to see what kind of damages they do, and you've got a strong stomach, you can Google these images and you will see a lot of human injuries related to unmanned aircraft. So the danger is real and the injury potential is high. So finally, the actual weight of your unmanned aircraft, and that includes perhaps any cargo or camera mounts on the bottom, will affect the injury potential. And certainly if we're flying at higher altitudes above people, the velocity of the unmanned aircraft when it comes out of the sky for a mechanical reason will increase versus flying at a lower altitude. So that will also affect injury potential. What about human interference? When we're flying in rural areas, not over people, we don't really have to worry about human interference. Sure, there might be a person that may come into our area of operation that we weren't planning on, but we developed contingencies to avoid them. Now we're going to be conducting an operation where we're flying directly over those people. So one thing to remember is that human beings are not predictable. You can't always know what they're going to do. So filming over perhaps a marathon race versus a protest or maybe a rock concert will guarantee that you have different results from those different people operating beneath your aircraft. So they may reach up to grab it. They may throw something at your unmanned aircraft. These are the things as the remote pilot in command you're going to want to keep in mind when you choose to operate over individuals. And I touched on this earlier, and we'll talk about it a little bit later in the presentation too, but the malfunction or a failure of the unmanned aircraft becomes more critical because what your aircraft may end up falling into. So your command and control links, or if you have life-limited parts, such as if the battery on your unmanned aircraft has a certain lifespan or a certain amount of times it can be recharged before the manufacturer says that the battery's not going to deliver 100%. Those are all pieces of information you as the applicant for this waiver are going to need to understand and mitigate in that application. So do you need to have a maintenance plan? We'll talk about that here too in a little bit. So the waiver safety explanation guidelines for operating over people are designed to help you with this process. They're designed to help you get a start on observing the risks that your particular operation, remember each operation is individualistic. You know your operation, you know your aircraft best, what type of risks you're going to pose. And it helps you get started on the path to do risk analysis and risk mitigation. Remember, when you're looking at those questions in the waiver safety explanation guidelines, we at the FAA need to know that you're going to ensure your operation remains safe at all times, and that if unusual circumstances develop, you have contingency plans or mitigations to help reduce the risk and avoid any serious injury to people or property on the ground. Now, with operating over people, it's a complex waiver. It's a higher risk environment, so that the waiver safety explanation guidelines should be viewed as a starting point in your waiver application, not the answer to, or not the questions that will give you answers to everything you need. Because when you're talking about your operation and your specific unmanned aircraft, you will need to provide additional information. Again, the waiver safety explanation guidelines, a good starting point, but don't stop there. Make sure you're doing complete analysis of your proposed operation to fly over people. So let's talk about the waiver safety explanation guidelines. And when we're talking about operating over people, there are 4 main data points we want to talk about. One is that when your unmanned aircraft impacts a human, we don't want it to cause a serious injury or worse. And that the data you're supplying to us not only addresses blunt trauma injuries, but also laceration type injuries. Finally, we'd like to get some information on your operating data and qualifications of the RPIC. So what type of conditions or limitations are you going to put on your operation to help mitigate the risk? And what type of qualifications is a remote pilot in command going to need to hold, or what type of training will they need to hold, or the person manipulating the controls in order to operate safely underneath your waiver? So let's get into our waiver safety explanation guidelines and walk through that. The big thing to remember, and if you saw our episode, I believe it was episode 2, which was risky business, we talked a lot about risk analysis, risk mitigation, and we referenced this chart. Well, now this chart is coming back to us here in our last episode because it's critically important when we're talking about operating over people. With this type of operation, we are constantly balancing the likelihood of a collision happening against the severity in terms of injury that collision would cause. And it's a balance factor. So if you want to look at this graph in the simplest terms, we want to stay in the green area. For example, if the likelihood of you hitting somebody is relatively occasional or maybe remote, but the severity of injury is going to be negligible, you may end up in a green acceptable risk area. Or let's say that the injury that your unmanned aircraft may cause would be very high on the injury scale, but the chances of it happening due to design considerations are extremely improbable. You also may end up in an acceptable risk area. So keep this graph in mind as we go through the next few slides, because I'll mention it a few different times as we move along here. So the first waiver safety explanation guideline talks about if or when the unmanned aircraft hits an individual, we want to make sure that it does not cause a serious injury or worse. So we want to know, has your unmanned aircraft been tested to determine what injury level might occur if it were to hit a human? We need to know this information to help determine the injury level. Again, go back to that risk matrix. The injury level plays an important role in determining the acceptable risk level we're going to move forward with in your waiver. If it's a high injury level, a very severe injury, or a very minor injury level, we need to know that your unmanned aircraft has been tested to that information. Now, I want to add in here real quick because a lot of folks put in their applications that they will use the Assure study as their method of testing the injury level of their unmanned aircraft. The problem with that is what the Assure study really showed us is that we don't fully understand impact injuries or necessarily how to model them at this point. That we may have made some wrong assumptions about unmanned aircraft, and that results that we got back turned out maybe differently than we were anticipating. So we require further study on a lot of these issues. The reason I bring this up is because a lot of applications have Assure study noted in their application as they're testing for impact injuries, and that does not work in a waiver application. So please don't submit a waiver application with a sure study as your method of testing impact injuries to human. So when you do provide us with some data, some testing data for impact injuries, we want to know how and when the testing was performed, as well as the data you got back from the testing. We want to know that because the impact injury for most unmanned aircraft posed to humans, it can be severe. So we need to know how you perform this testing to determine an injury level. If you're going to say that my unmanned aircraft could cause nothing but a couple of scratches on someone, okay, how did you come up with that data? Because we need the data from you not only for reference for our risk analysis of your application, but we also may need to go out and test and validate the data on our own. So we need to know what you did and how you did it, especially for higher risk operations, operating over, let's say, a lot of people, or operating a heavier UAS over a lot of people. That information poses a higher risk, so we need to know how your testing data came about. If you're not going to provide testing data, and that's a common myth out there too, is that everyone must provide testing data for their unmanned aircraft. That's not wholly true, because if you're not going to provide testing data, you need to provide data that shows how your unmanned aircraft would not hit a human. So whether that's through design assurances and failure rates, or just the construction of your unmanned aircraft would prohibit it, we need to know that information. So certainly the most complete application would have both sets of data points in it. But if you're providing testing data, or I should say if you're not providing testing data, we need to know what information you're using to show us that your unmanned aircraft is not going to hit somebody. So the data you're providing in terms of injuries is important not only for the rotating parts, the rotor blades that you have on your aircraft, but also the design of the unmanned aircraft itself. How could that potentially injure somebody? So while most people think of rotor blades right away as that's what's going to cause the injury, the actual design of your unmanned aircraft could cause injury as well. The payload you're carrying, the shape of it, whether it's a rigid structure or something that's frangible that would break apart upon impact. Provide that information to us so we know how you're determining your injury level, because we need to know whatever you're doing with your unmanned aircraft, you're doing to reduce the potential for injury to humans. That's very, very important. Some people have design built into the unmanned aircraft, or operating conditions or procedures that will also reduce the risk. So if your unmanned aircraft is going to incorporate safety-related features that reduce the severity of impact, what are they? How do they reduce that injury? Parachute seems to be the answer a lot of people like to provide. And while that's definitely one mitigation, it isn't exactly the answer for every situation, because parachutes have different operating parameters associated with it. Some people provide that your unmanned aircraft has features on it that would limit the transfer of energy to a human upon impact. Think frangible. The unmanned aircraft would break apart rather than transferring that energy directly to the human. So if you're going to use something like design safety-related features, remember your application must contain details on that. How do those features reduce the injury level? Do they have any operational limitations? For example, we have parachute listed on this slide here. Does the parachute have a minimum deployment altitude? So if it's a minimum deployment altitude of 50 feet above ground level, and you're proposing to operate at 30 feet above ground level, those numbers don't work out. So what type of limitations do you have on those design features? Now, I mentioned this before about if you're not going to provide testing data for impact injury, we need to know how you've determined that your unmanned aircraft is not going to hit somebody. So we get into something that we reference in the waiver safety explanation guidelines as determined level of reliability. This is an assumption that your unmanned aircraft will not fail or crash. If you're going to go down this route where you're going to show us a determined level of reliability, we need you to show us that you've got some sort of mean time failure testing data, that you've got a reliability or a maintenance program, that if you have life-limited parts, you have a process to identify what parts those are and a procedure to correct anything that may be reaching its life limit. What about the system architecture or hardware reliability analysis? Certain things like software design, assurances, control, anything that's operationally restricting or limiting your UAS, which is going to enhance safety, we need to know, particularly in the realm of determining your levels of reliability. Now, a little bit of a note on determined levels of reliability. That list that I just gave you, which is in our waiver safety explanation guidelines, is meant to be just a guide, some examples for people to start the reliability process in their application. So it provides you really as the applicant areas to evaluate, to include in your design assurance assessments. But just like the waiver safety explanation guidelines themselves, that list that I just went through is not a complete list, certainly because everyone's operation and everyone's aircraft is different. Make sure your design assurance list is complete, telling us what it is you're doing, how that's going to reduce the injury, and how you're going to incorporate that in your operation. Because we need information on every one of those design assurances that help you with the determined level of reliability. A little bit about the remote pilot and command. The remote pilot and command has to understand these design assurances. If there are features that the UAS has, or if there are procedures that you are incorporating in your operation that are going to reduce the risk level, that will enhance safety, please describe those restrictions, including how did you determine that that particular restriction is going to reduce the likelihood, think back to that graph, or the severity of your flight. So if you're going to fly and it's got a hazard reducing or severity reducing component to it in terms of operational qualifications or restrictions, how did you determine that? How will it prevent the injury, whether it's a serious injury or greater if a human were to hit? What hazard is the design feature or restriction there to reduce? If it's something very unique to your UAS, don't assume that we understand exactly what you're talking about. Be very detailed and specific. We want to know how each of these operational restrictions or design hazards reduce the impact, injury, or severity, or reduce the risk in your operation. So some things that we have seen for operational restrictions that help enhance safety, they limit the operation itself, lowering the altitude to reduce the impact velocity, maybe avoiding intentional operations over people. You might be saying, well, if I'm avoiding intentional operations over people, why would I need a waiver? Well, perhaps you're doing some type of work where you're flying where once you're up on station in a mission, you can't move the UAS from that spot. And if somebody were to walk underneath your unmanned aircraft, you don't want to have to scrub the mission. So that is something that you could put into your application that, hey, as the norm, I'm not going to be flying over people, but I need to have my UAS stay on station if somebody happens to walk underneath it. What about additional remote pilot training? So, for example, if you're using an airbag or a tether and there are certain procedures that must be followed, or there are certain limitations associated with that operational restriction, how are you ensuring that the remote pilot in command or the person manipulating controls is trained on that equipment? Do they understand the limitations? Do they know how to use it effectively in a worst case scenario to avoid that higher risk or the more severe injury for operating over someone? So operating over people is not a simple waiver. It falls into one of the more complex categories, similar to beyond visual line of sight, but it's not an impossible waiver to get. Remember, when you're applying for a waiver for operating over people, you need to understand all the risks and provide enough mitigations to reduce those risks to an acceptable level. That's the big key component with any waiver, but in particular with operating over people. And then don't forget all your responsibilities as pilot in command. Just because you were, let's say, get approved to operate over individuals doesn't mean that you don't need to worry about 107.23, the hazardous operation. All the other restrictions are still in place. And most importantly on this page, make sure you include all supporting testing or all supporting data that you're providing. Not only what the data is, but how the data works to reduce the risk, how you came to the conclusion that it reduced the risk to a particular level, and provide enough information to the FAA that if we need to recreate the test that you did, we have the data to move forward with that. So our website is still up and running. As always, it's your great one-stop shop for everything you may need. Our drone zone documents are where you're going to find your waiver safety explanation guidelines and waiver application instructions. And then this being our last episode in the series, number 9, we will post it to our website as soon as we get it ready, as well as the questions that were asked in all previous sessions. They're also posted up on YouTube, but your one quick stop shop for that is our webinar series website, and you can see the address on your screen below. So that is going to wrap up our summer webinar series. It's been 9 episodes that took us all through the summer. The weather's getting colder here where I live, which means that summer must be over, and our summer webinar series must be over as well. But do not worry, we have more information come to you folks. Stay tuned. We are going to stop this summer webinar series, and we're going to go work on our next one here to have it up to you as soon as we can. If you want to be advised of when that's happening, follow us on Twitter, follow us on Facebook, check to make sure you have a valid email address in your registration profile so that we can get the information out to you.